Okay, so let's get started. Sorry, the other TV are not functional, so we're gonna use the one on your left and my right. Welcome back. I hope you enjoyed Costa Rica. So I was putting together a little bit of data for you, and then we're gonna do an exercise on it today. Mostly we are gonna work on Lab 5 today, which continues some of the concept that you can use for your project. So the plan is today we're gonna do Lab 5. Tomorrow we are going to work on GUI, along with maybe Wednesday. It depends on how soon we can finish. And then I want to spend at least one day working on the project, or at least getting you started with your project. Now, if you did everything and got perfect score on everything, you have an option to not do the project, which reduce the grade to 15% less of your entire score. But I encourage you to do something with the project. That's the whole point for the trip. So we'll talk a little bit about that. All right, so today I'm going to go over the concept for Lab 5, right? Some of the project requirement cover the concept, so we want to be able to add these components to our project. So if you click on this, you are going to download the CSV file that I created for you here. I'll explain that. This is a file that contains all the bird species in Costa Rica. I spent a couple hours entering all the data based on the booklet and some of the information that I got from the trip. And then so that way you have a set of data to work with, so you can visualize it for number 12. We are going to work through the exercises starting with number 1 from Lab 5. Okay. So first thing first, we are going to open up Tawny, log into your computer, and search for Tawny. We're going to use this to write our program. And if for those who are working from home, if you don't have Tawny, you can install it. And it works on Mac, Windows, or Linux. Okay. So before we start with your assignment, I want to kind of talk a little bit about what we're going to be doing. So the first part of the exercise, or the first few exercises, we're going to work with exception handling. And exception handling is a way that we manage error in the program. You should always expect some form of error, especially when you have user entering the data. So when you're asking the user to enter their name or their home address, etc., we want to input validate, but at the same time, we would expect some form of error. Or sometime in our program, we might run across data or values that would generate error. So we are going to use what's called exception handling methods. And these are going to be the procedures on how we can, instead of stalling the program or stopping the program, we would overcome that by using some of these statements. So in Python, there are some exceptions handling statements as shown here. You would see that we can use finally. This happens no matter what. So when you're using finally, it's going to show whether the error occurs or not. Okay. We can also assert, so we can trigger some kind of actions for error. We can also raise or trigger the exception. So whenever you hear the term exception, that is just for error, right? Or some kind of irregular occurrences that's happening in the program. So when you test your program, sometimes you want to use the raise command, and then, or we can try to insert something and then be able to handle it. Okay. So this can be used for testing, or it can be used to control our program so it doesn't stop when error occurs. So the example here, what I want to do is to show you what that will look like. So in this example, I have 3 inputs, a letter A, a 0, and a 2. What I want to do is I want to tell it to loop, and it's going to try to take 1 and it's going to divide it by some kind of value. So the letter A, it's going to convert that to an integer. And if it's able to divide, right, it's going to go forward and it's going to print out the value. If it's not able to divide, for example, when it gets to the 0, because I have 3 input, the second input, if it 1 divided by 0 is going to trigger an error. And when it sees the error, what it's going to do is going to give me this print. So the except here is when it's handling the error, right? So it's going to try to insert each of the value, and then it's going to show accordingly. So in the case where if we take 1 divided by 0, it's going to create an error. It's going to go to the except option or that block, and it's going to show that it is an error has occurred. But we're using the module CIS here. What that does is it's going to give us the type of error that we see. So when you're testing your program, sometimes you want to use this library or this module to be able to see what kind of error your program will generate. Okay. So let's take a look at number 1. Let me zoom in real quick. Okay, so we are going to make a program and we want to validate the user age, right? Like we're going to ask them to enter their age, and it has to be between 1 and 120, right? We can go a little bit higher in range, but I think maximum age is about 120, right? The minimum age is going to be about 1. We want to ask the user to re-enter the information if they don't input it correctly. So if they type in a letter or something that's not in this range, right? Like 130, they are going to have to re-enter the information. So here I kind of lay out the step. We need to make sure that we have some form of input. We are going to use the try and accept to apply the conditions for our range. If it is valid, then we are going to show the value that they enter. If it is invalid, we're going to ask them to re-enter again. So here we are going to make a while loop. Okay, so this is what the program is going to look like. Let me put this down. Okay. So I have at the top a variable called age, right? And let's think of this as a way that we can validate the user age, let's say for a store where they have to buy some kind of, I don't know, materials, products, or whatever that needs a certain age limit. And in order to enter, because it's text, you want to parse that into integers. So therefore, in the front, you would have int. And we would use the input to prompt enter your age. And as you can see, I put the comment global because you want to put that at the top. So that way that variable can be used inside the function, which is right below it, right? So I have a function called getAge, and we define the function by using det keyword def. And we want to say while true, while this is true, we're going to try to assert age. That means we're going to plug in whatever the user has entered. And as long as it's greater and equal to 120, and the age is less than and equal to 1, right? So whenever you have a range, for example, between 1 and 120, you want to use the operator and. So you want to say 120 and 1. That's how you can use a range. So instead of using the if statement like what I've seen below, right? When you're using the if, you can also use if age is less than 1 or age is greater than 120, then we are gonna ask them to indent it. So you don't have to type in the comment with the if and all the stuff that has to comment with just the hashtag in the front. I only put it there as an optional way to do this program using the instant. You only need to put in the ones that are common. So we are gonna assert, that means we're gonna try, we're gonna put in, right, we're gonna try to apply the value that the user enter as long as it's in that range, okay? So if it is greater and equal to 120, we're gonna tell them that it's invalid. If it is less than and equal to 1, if they put in 0, right, it's gonna say invalid. So the assert there is equivalent to like an if statement. If the age is less than 1 or greater than 1. And we are gonna print invalid input, try again. Then we have a block called except. And you notice that every time that you deal with a block, you have to indent. Make sure that we indent after the colon. So we are going to handle the exception in the case that is error for input. We're going to say except exception, print invalid input, try again from the except. And we're going to break. So that break, what that does is going to pick up on the next block, which is except, and we want to put in the type of error. So if they type in a certain input that is not in that range, it's going to see it as an assertion error. So we want to say assertion error, and it's going to give you the output assertion error occurs. We're going to break. So the point in this is you expect multiple type of errors. Number 1 is user input not in the range that's allowed. This is used for input validation. Number 2, it could be that also they input outside of that range, but in a different way, like 11. And then for the else, we want to print it out. So if they input everything correctly, it's going to go to the last statement on line 22, and it's going to print out everything. And lastly, we would call the function that we define, which is get to. So this is an example of how you can use input validation using exception handling. And this can be used for your business. Let's say that Danny creates her salon and she asks the user to input their name, right, and their age for the appointment, right? And you want to control because you want to make sure that whatever they enter is correct. Okay, so we can make sure that we validate the input. Or this can be used for like retail store, things that people would buy with a certain age limit. So when you run this program, if everything is correct, okay, it's going to ask you to enter your age. So let's say I input a valid age like 30. So because 30 is inside that range, it's going to print out 30, right? It's between 1 and 120. So it's fine. And then you notice that on the bottom, it says invalid input, try again with except. Where does that come from? It comes from the except exception, right? So that line prints no matter what, right? Invalid input, try again with the except. Now, if I enter a value that's outside of that range, and so you can see when I run this program again. So here you can see that it ran this as well, right? After it checks. So we're going to run. Let's say I put in 140, right? So it's going to do 140. It's going to show that my age is 140. And it says that invalid input, try again from the accept. Okay. So either way, what happens is it's going to go here no matter what. So when you try this, okay, it's going to check if it is valid, if it is within the range. It's going to print this. Okay. Now, if I use a different number, right, it's gonna, as it goes through, it's gonna assert this. So it's gonna break and it's gonna show again invalid input, try again. Okay. So let me see. So the whole point in this is, what if I put in a different statement here, right? What if I say, like this? Let's check. See how it happens? It's always going to go to this section right here. So if this is true, or this is false, it's going to go here. Okay. See how, and while this is true, so in the case where when we say that 20, it has to be true on both ends because we're using and. Okay. Now, if I use, so you can test this and you can see. So now if I do, let me see. If I put in a letter A, right? See how when I put in a letter A, it's going to stop my program because at this point, A is not converted, right, to the range. So it's going to halt your program there. Okay. So how we can overcome this is we would be able to put in the type of error here. So this is a value error. So you can say except value error print, right? Value error occurs. So I can add in another block to handle this and it's going to overcome that. Do you see what I mean there? If you replace this like this. Sorry. And then we do another break. So that's how you can handle, like if they fat finger and type in the A or the B, the C, the D, right? Instead of a number. Okay. So you can add in, so in a program, normally the developer, they would expect various errors, and this is how they're going to be able to handle the error. Okay. Let's see. It should accept, I think for my program, it's not very good there. Any questions? Let's do another program. I think this one is subpar for me. Okay, so for number 2, we are going to do a different program. In this one, we are going to accept input between 1 and 10. And we are going to raise an exception. We're going to manually cause an error, right? When the input is not within the range. Okay. So in this one, we're going to use the raise statement instead of the try and accept. So in here, you are going to use try and accept. Okay. For the next one, let's try number 2. It's really easy. So I have a number that I want to record as input, and that's going to be between 1 through 10. So it has to be greater than 0 and less than 11. And I want to print out the number if that's in the range. Otherwise, I'm going to raise an exception and I want to put invalid number. So this is a little bit more accurate. Oops. Okay, so let's run this. So if I input the number 5, right, it's going to show that it is the number I entered is 5. Now, if I want to put in, let's say 20, right? See how it shows the exception? So in Python, it's gonna show this as a traceback, but at the end, there's a message. Exception invalid number. And that comes from your else block here. Okay, and that's how you can manually raise an exception. So in the case where if you know that there potentially is an error, you can have it raise an exception. But this can also happen in like automatic input with servers, on like web applications and so on. So whenever it handled the exception, it doesn't output in black letters like what you've seen. It's going to show that in red as a message there, right? Because it is an error. It's an exception in the program. And this can be used in many forms, right? Like we can make a game where people can wager or they can pick a number, and the number has to be between, let's say 1 to 50, right? And anything outside of that, they do not pick. We can also, you know, do this for like input in inventory, stuff like that. So there's many applications in this. And exception handling is not just in Python, it is in all programming languages, right? Syntax is a little different. Python is a little easier in how we would write the statement like this. So if you want to manually show or raise the exception, you would put raise and then exception like this with the capital E. So if it's valid, that nothing is raised. So it just shows like a normal program. Any questions? Okay, this one is pretty easy. So in this one, we use if else and raise exception. Okay, let's look at the next one. So here we are gonna make a program that is gonna ask for your name, and we're gonna use assert statement like what we've seen in number 1. We wanna make sure that it is alphabetic, and we wanna use the raise exception, right? To make sure that they don't enter the numbers. Okay, so this is number 3. So what you have is you are going to do try and accept. Okay. Whenever that you see that we are required to use assert, you need to make sure that it is part of the try block. What that does is it's going to attempt whatever that the user input, it's going to check for this. So assert is equivalent to like an if statement. If this is alphabet, right? It's going to show their name, and finally here is going to print regardless whether you come across an error or not. It's going to show thank you at the end. Now, if they input that is a number, if their input is a number, right, it's going to show value error, and it's going to display this in red. You did not enter the correct name. So let's say I put in Mary, right? So it shows that I had entered Mary because it's alphabet, right? So it validates this. So this is true. It's going to print my name. It's going to go to the else. And it's going to print out finally section, no matter what. If I run this again, and I put in 1, 2, 3, right? See how it's showing that it's handling my exception. It shows my value error, and it prints out the race exception information. You did not enter the correct name, like this. Okay. Now, on the web app, normally we would handle this with like a message warning box instead of showing in the console like this, right? So what you will do is you would include, right, and I will show you how you can add that widget starting tomorrow. To be able to give them a warning, like, oh, you did not enter the correct name, try again. So it's gonna re-pop them the text box so that way they can see it. But in the console, this is the only way that we would show the message if we have an error. Okay. And you notice that, you know, we want to use the finally, so when it gets to that, right, it would be able to show. So if they enter it correctly, it's gonna show thank you. Okay, so this is how you can input validate. Now, if I want this in numeric, I would say, right, is digit. So if you ask them, enter your phone number, and you can validate it by saying assert, right, phone dot is numeric or is digit, and then we would handle the exception. Any questions? Okay. So this is an easy way that you can use exception handling for input validation. So while we are looking at that, so take a look at the example in your notes, right? I show various examples that you can look at how you can use race, how you can use try and accept with race. There are different type of error, like runtime error. So runtime error occurs with the interpreter. So sometimes that can happen with the system. So you want to kind of display the message. You see this quite a bit with operating systems. Sometimes it shows the little box saying that you have an error. You have to go and fix this or configure or change your settings. Any question on these? 1, 2, or 3? Okay, so one more on input validation. We are going to write the program and we're going to ask for their phone number. We're going to use assert and accept. So you're going to do try, assert, accept, just like what we did before, and make sure that it is for digits. So just like this, but instead of alphabet, we're going to do it for digits. Okay. So let me reopen my program here. Okay, so this is for, first you are going to start with the try and then indent. So here we are going to define a variable and that's going to record the user input. You can ask them enter the phone number. Here I just put number. Let's see. Then because this is going to be text that they enter, right? We are going to treat it like a string. And for the string, what we want to make sure is it's going to be 10 digits. Okay. Because phone number is 10 digits. And you see this with social security number. You don't want people to leave out like 1 digit or 2 digits when they enter. That happens, right? When they're in a hurry to type or sometimes they miss a space. So we want to make sure that they enter all 10 digits for their phone number. So in this, what we're going to do is we're going to check all the 10 digits are there. So you would say assert the length, right, of the phone because we treat it as text enter. We don't have to convert it to integer. then we're going to validate it by handling the exception. So you would say except, and we want to say value error, not a digit when they're inputting like a letter. We also going to expect another form of error that they don't have enough digits. So it's going to handle two parts. One, they enter letters instead of numbers. Two, they're going to enter less than 10 digits. Okay, so it's going to check and make sure that this is 10 digit. If it is not true, it's going to go here. Okay. If it checks for the phone number that is a value error where it is letters instead of numbers, it's going to go here. If they enter everything appropriately, it's going to go to the L section where it's going to print the phone number. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So it tells me that I have a good phone number. I'm going to run it again. 1, 2, 3, 4. And it tells me that I don't have enough digits. So this program works, right? It tells us that if I only input 4 digits, it's going to go here. It's going to say that this is assertion error, not enough digits. And you notice that the type of error is highlighted in purple, as those are the appropriate error that the interpreter understands. So this is how Python is created. It uses specific type of error. Okay, so when you use assert, and if it's not less than 10, it's considered that as an assertion error. If we run the program and we put in A, B, C like this, right? It tells us that it is not a digit, so it's going to go here. So the letters, as it's not recognizing that as numbers, it's going to see it as a value error. So it shows that not a digit. Any questions? So you can test it with all kinds of different input to see. So ultimately, it's going to take in the input, parse it as an integer, right? And then convert it into a string, which is a group of characters. It's going to check the length, make sure that it is 10, right? And if it is not 10, it's going to go to assertion error. If it is correctly done, then it's going to show good phone number. If we put in letters instead of numbers, it's going to show is not a digit. It's going to show it as a value error, because it's different type of input. And that's how you can handle input validation with handling exception for phone number. Or we can do this with age. We can do this for social security number, driver license. Well, driver license in California, you have letters and numbers, so you can check for alphanumeric. Any questions? Okay, so don't forget we indent after the except and the try, and then for the try, we can use assert. And whatever that you assert, you would check for the true condition there, okay? It has to be the true condition here. All right. So that wraps up, I believe, exception handling. So now we're going to talk about object-oriented programming. This is a little bit more complex. I'm going to try to break it down and make it easy for you. right? Most students, they fear this, but this is used in all programming languages that are object-oriented, and Python is one of them. C++ and Java is the other. So in number 5, it asks you to create a student class. So we have to have a class called student, and you want to capitalize the class name, okay, by practice. And we're going to have the attribute name, ID, and gender, okay? So think of attributes as characteristics of students. It's kind of like how you have specific characteristics, like how you have curly hair or straight hair, certain skin color, etc., right? Or you could be a certain age or a certain gender. So here in this case, we want to use the attribute name, ID, and gender. That is just the characteristic of student. And we want to use function or methods to be able to have actions. So what I'm trying to do here is I'm trying to have student register for their class. I'm going to have a function called register, add course, greet, and print course. So we want to welcome the student, ask them to register for their class, add the class into their class list, and then print it out. Okay. And we want to be able to allow them to have a list of courses, and that will be a certain attributes like this. Student 1, Lila, right? Her ID number, she's a female. She registered in these 3 classes. Okay. So in a class, on page 4 of your notes, let's start with defining a class. So when you create a class, what that does is it creates what's called a namespace. And within that, it ties in the attributes. So what it does is it creates a location to store any kind of characteristics that's related to that class. And so it's always going to associate those attributes using objects in that class. Okay. So think of it like you have a last name that represents your family. Okay. And your family has certain attributes, like you are a certain race, your family is a certain race, you reside in a certain location. So in this right here, what we want is we want to create a class, and we want to create an object that would represent that class to be able to access the characteristic of that class. Okay. And so it would be something like this. Here's the class. And often in Python, you would see an init function. What this represents is going to create a namespace for that class. It is itself. And then any kind of variable you want to use, you want to pass that inside the parameter here. Okay. Like ID, name, age, etc. Here's the object called P1, and you can name it anything you want. Normally, we use a short name for object. And it is an object of that class because we're going to bring down the class name here. And this is where we're going to apply the value. This is where you're going to pass, right, their name and their age. And you can simply print out the object and its name. So its attribute, and then another attribute. And so that's how you can have an object to access the attribute in its class like that. And I think for Python, it is the easiest to visualize class compared to other languages. Okay. So using this example, you are going to write. So let me open up exercise 5. This is a little long. Okay, so I have a class named student, and whenever you create a class, make sure that you use the parentheses and the colon. After that, you are going to indent. So we have a class called student, and we want to make sure that in this class, we have a list of courses. That's what the exercise requires. Okay. Now, this is definitely not required, but normally by practice, I recommend that you put an init function. What that does is it is a constructor. It builds that class. So it is a way that it actually builds a blueprint of that class. It's kind of like a map for that class. Okay. And this is the way that the system can see, right, what is related to that class. So we would have a function called init function, and it is itself. This is just a placeholder. You can name it anything you want, but by practice, the industry, they use self, right? So here we would have self. And then we want to say print, thank you for being a student. You can say MVC, RCC, Norco, whatever you like there. And I want to have a member call or the attribute called name. So here I would say self.name. And I want them to enter their name. So input, what is your name? Then ID, I would say self.id. So what that does is going to plug in each of the attribute as it goes through. Name here, ID here, and gender there. So it would say self.id, and I want to parse this as numbers. So I would say int input, enter 4-digit ID. Now we did input validate here, so you would want to include other area for input validation in a complete program. Okay, so when you write this program, it's a basic program for like course registration, so it works. Then gender, we ask them for their gender. Now here are the member function. What these are the methods or actions that we can use in that class. Just like a regular function, but we want to put that function inside a class. The benefit of that is when you use methods inside a class, you can control that class more secure, right? In an application, we can also not use all the methods. Okay, and we can use it in some areas and not others. And so we can also apply inheritance from one class to another. And I'll talk about inheritance. So in registration, we want to say a function called register. And again, we're going to pass the self. Here in this function, I'm going to use num because this represents the number of classes that they're going to register. So after I do that, I would ask them, how many classes do you want to register? 1, 2, 5. So let's say I want to register for 3. I would enter the 3. It's going to take that 3 and it's going to plug it into the next function, which is add course. So it's going to let me add 1 course, 2 course, and 3 courses. So when you use WebAdvisor or EduNav, this is what's happening in the back, right? You already logged in, so it's already have your information. And then you click that button, register for class. It's simply a function register. And it would ask you how many class. Normally, EduNav let you only add 1 class at a time, right? But then it also have a limit, like you can only add 18 units, so they control it by the unit. So in this case, we allow the user to put in the value of classes that they want to add. And we are going to use this function to call the next function. So you can see that's how it's done here. And then after that, we want to have a function called add course. And we want to bring down the number of courses they're going to add. And since it's more than 1, we're going to use a loop to make sure that we're going to add each of the course. So in this case, we're going to let them type in the class that they want, right? Like CIS30A, or it could be that they can type in like introduction to C++ or calculus. And as they do that, it's going to append it to this list at the top, which is a global list, a container that's going to store all the courses that they type in. So once we add it to the list, we want to be able to print it out. So I have another function called print course. And as it is a list, I need to loop through each of the course that's added in the list, and I want to print that out. And then lastly, I have a function called greet. Sorry, I have to have all the class objects. And here we want to say hello and then their name, show their ID and their gender, right? That's the profile information for that student. Now, once you have your function defined in the class, those are called members function. You are going to create objects, okay? This is how you can access attributes and methods. You can use the object to access the functions in the class, okay? So to create an object, I simply give it a name, student1, and then I would have the class name. So that object belongs to that class. It's kind of like how you belong to your family by your last name, right? So in the system, we have to say, this is the object and it belongs to this class. Once we do that, we would then be able to access the function in that class, like register, add course, which we previously defined. So all the function that we defined above here, we would be able to call them here. Okay. By using the dot operator. So you would say object dot method, object dot method, object dot method. Now, as I have more than one student, because you don't want things to override, so we want to have student 1 that will be storing the information that they register, right? And they input. Student 2, that's a separate person. Student 3, that's the third person. So what you learn in this is you have to define a class. Inside it, we would have variable that would store attribute information. Then we also have functions or methods that allow you to have action in that class that can be accessed by the object. And then lastly, you would define your object here, right? So each of the object is able to access the function accordingly. Now, ideally, we would use a database, right? So what will happen is we have to take that information that they entered with the object, and then we would bring it over to the database and put it into the database. So like the function register, we would be able to store that, right, with the classes that they input. And then the ID, the name information for the greet, and so on. As I have 3 objects, it's going to ask for all 3 of them, assuming that there are 3 students are registering, right? So after you test the first one, you would see the second one and the third. So you would enter their name accordingly. So after the third student is entered, right? You would see the list of the classes that it registered. Any questions? So you would always have an object in the class, and that object is used to access the components of that class, such as functions or methods and attributes. Okay, so don't forget to screenshot as we run through these programs. And then put it on the document so you can submit it for today's lab. I'll have the recording up tonight, so in case you miss something, you can go back and look. So earlier I mentioned that when you use the init function right here, whenever you see this, it instantiate that class, right? This allows you to, it maps out like the attributes for the class here. Okay. Now you don't have to have this, and I'll show you some example that doesn't have it. But so Python does this in the back already. Okay, but technically we should do this because it's just appropriate. And this is part of object-oriented programming. So this is only one class. We can have many classes. Like in your family, you would have your immediate family, and then you also have distance family, right? So you can have grandparents, parents, and grandchildren. And the grandparent is the super class, and then subsidiary, you would have parents and then the grandchildren. Okay. So we would talk about inheritance shortly. Let me double check. Any questions? Okay, so test your program. It's gonna ask you to enter 3 students, right? And then put in the courses. You can type out the course name or the course letter. Now relating this to, I know Pedro was talking about like how they were having ticket issues for that one place that we were visiting, where they can only sell up to 20 tickets at a time for each group, right? You can have a class called ticket, and then with that, you would have like company information. So you would say company name as an attribute, you know, amount or ticket amount, etc. So that would go under here. Okay. And then I would have function, right? Like purchase. And then or add tickets or purchase one ticket, purchase multiple tickets, etc. So you can write multiple functions and then create object to represent the ticket purchases. You don't have to have 20 objects. You can have objects that's able to access different attributes to save space. But this is an example of you can store 3 separate objects. Okay, any questions on this? You need more time on this? Okay. Okay, so here there's some example. So you can also use the example looking at how you can also update the object. You can also delete it. So there's a thing called polymorphism. This is very important in OOP for object-oriented programming. This really refers to the representation of different types in different scenario. Like you can have characters input, you can have values, you can have things with the operators where it combine or add. So that allows it to apply the condition in different forms. Okay, a lot of people think polymorphism is a little different. So for the computer science students, a lot of the companies, they like to ask about this when you apply for a job, especially if you put down that you know OOP, right? You have to explain what polymorphism is, right? It's a way that you can apply condition in different forms and your data can be in different types. So that way you would use operators and methods to apply to different types of data that's being input. Okay, so we're gonna do another program, and this one is on cars. Okay. So we're gonna have a class called vehicle, and remember, we're gonna capitalize the first letter in that class. And we're gonna use the class suite, which includes members like functions and variables. And we can also use statements like conditional statement in that class. We're gonna have two types of vehicles, so we're gonna have two objects. We're gonna make sure that it includes make, model, color, year, and price. And we can use this for car dealership, or you see like those online car delivery type of retail. Okay. So here, what we have is we're gonna start with the class definition. Just like what the program requires, we're going to define our class vehicle. And notice that I don't put the parenthesis here, right? It's not required. Normally, you would use the parenthesis if you pass some form of operator. Pass a form of values or variable. And in this case, we don't, okay? And then the first function is called the init function. What we're doing there is we're gonna instantiate that function using those attributes. Make, model, right? Color and year. Those are the attributes of our vehicle. And so within that, we would have to say it is itself. And we are going to use the member variable make, model, color, and year. And those are instances or instance variables. It's instantiated for that class. Okay. That's number 6. Then after that, I have a second function. This is a member function. It's going to show the information like the make, the model, the color, and the year of the car. So I'm going to print self.make, self.model, self.color, and self.year as they are defined here. So normally you would use the init function to define your member variable this way. Now, in other programming languages, it doesn't use the self dot, right? You normally would have a constructor using the new keyword like in Java and Python, you don't need that. You just instantiate your variable, your member variable in that class this way. using the south, which is like a placeholder. Then I have two objects, vehicle 1 and vehicle 2. And here is what I plug in. So this is, we are hard coding. That means that we're going to plug in the value. So it's going to take Chevrolet and it's going to plug it into the make. Model, Corvette, it's going to plug that into model. Red is plugging into color. And the year 2021 is here. Then for the second vehicle, we're going to have Ford. So when you create the object, make sure that you put down the class name. And whatever that you're going to pass for each of the attribute, as you noted here, you are going to put the actual value inside here. Okay. So Ford, Mustang, black, and then the year. So after we have the object, we are going to use the object to access or call the method. So you're going to do object dot method. Show info, show info. So it's going to show Chevrolet Corvette red 2021 as make, model, color, and year. So can I simply just write a program without classes and just have them display like, using variable? Sure. Or a list? Sure. Or even a dictionary? Yes. But to really design it with object-oriented, meaning that we would have object to access. Number one, you are going to have better performance in your application. Number two, if you're using classes like this, you are better control in access. So in security for the application, we can manage how each of the attributes can be accessed across multiple classes. So there's benefit in OOP design for your program. Okay. Now for your project, I don't require classes, right? As normally I would, but since it's a short term, if you do add your classes in your project, I would give you extra credit for your project. But for computer science students, make sure you practice this because you will see more of this later on. So. And if you take like the higher level Python courses, you will definitely see OOP classes. All the libraries that you use, they are written in classes. So it is easy to read the library if you know what classes are and how to use them. Okay, and then when you run this program, it's simply going to show this, right? We don't have any kind of input. So whatever that you put in here that's hard-coded, it's going to plug in here, 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 and display. Very easy. Any question? Okay, on the final exam, there's some questions related to OOP. Make sure that you look over the final review that I posted for the test. All right. So now we need more time on this, or we're okay to move on? We're good? Okay, the next few are pretty easy. So for 7, we are going to answer some questions. It says refer to the notes I might have put week 4, but I meant week 5. Explain the difference between a class variable and an instance variable. Okay. So if you go to your notes, on page 7, it tells you this here. A class variable, which is shared by all class instances and objects. So earlier we saw that we have vehicle 1 and vehicle 2, right? Going back to this program. Okay. So this is an object and this is an object. This is a class variable. It is shared in all objects in that class, you see? Okay. Whereas the instance variable is unique to the instance of that class, it is defined inside the function or the method. It is only applicable to that instance. So when you have a function that has its own variable, that is called an instance variable. Okay. So you would see that's defined underneath the function like this. Okay. Like this one. You have ID and name, right? That's specific to that function. Courses, that's specific to the function. Okay. Whereas this one, these are shared with all the objects. Okay, so this is the class, the other is the instance. So here's the answer. Let me move this to the next page. You can type it into the assignment questions or the document that you have. So a class variable is the variable shared by all of the class instances and objects. So all the functions and all the objects inside that class can access the variable. Whereas the instance variable, this is only for the instance of the class. It's inside a specific function or method. And it's only applicable for that class. Okay? Make sure we know this for the final. You can also go to page 4 and pull the text and add it to the answer page. Okay, next question. It asks you to look at the script, and what you're going to do is you are going to identify which one is the class and which one is the instance attributes. Okay, so on your notes, on page 4, it talks about attributes. So your data attributes or your class attributes are linked to the class that's defined. So it should show like class dot something. And your data attributes is just for the instance. It's not shared by the objects. Okay, so it's very easy. So I highlighted in green is the instance attribute, which is going to be the attribute specifically for that function, like self.model and self.color. And then for the class attribute, since the class is car, it's going to follow car, like car.show, like this, right? And then Audi.show, like that. So you can simply highlight so you can know, distinguish the difference. So think of instance attributes as something unique to yourself, right? Like let's say that you belong to a family, but you have curly hair and everybody else have straight hair. So instance attribute is the curly hair. Okay. Now in your family, right? Let's say that your family, everybody's Hispanic. That's an attribute for your family. So that identifies the class, the characteristic of that class for the object to access. So that will be your class attribute. It relates to that class. Instance, it relates to specific method or specific component of that class. Okay, almost done. Just a few more to go. Any question on this? Okay, make sure we know the difference for the final. All right. So now for number 9, we are going to describe the 4 types of inheritance of that class. I'll show you where you can find this. In your notes, starting on page 8, you can find specific inheritance, but I'm going to put up my response so you can see. So you can have a single inheritance of a class where it inherits the methods and the attributes from one parent class. Just like how you inherit traits from your parents. That's a single inheritance. For example, let's say that your parents have brown eyes and you inherit that trait. So that's considered a single inheritance. Right? And some families would have different traits. So it passed from one generation to the next, one class to the subclass. Okay, that's specific attribute. That's going to be single inheritance. And then you have multiple inheritance, where you have a child class that inherits from other classes. Let's say that you inherit from your parents and your grandparents. Okay, so let's say your parents have blue eyes and your grandparents have dark hair. So you have both of that traits, and that will be multiple inheritance. So it inherits from multiple classes. Then you have multi-level inheritance. That's different, right? It says that it inherits methods, functions from other classes that inherit them from other classes. Let's say that you inherit a trait from your parents who inherit traits from their parents. So ultimately, you inherit traits from your grandparents. So it is passed through the parent class, a subclass, and the grandchildren class. So 3 levels. That is called multi-level inheritance. Then you have the 4th type, which is hierarchy. And this occurs when you have one or more classes derived from a single parent class. So let's say that your grandparents, right, pass the trait to your parents, also to your aunts and uncle who are separate class, and then your cousins. Okay, so that is a hierarchy. It's going to go from the top level, which is your grandparents, to your parents, and then other base class in between, like your aunt and your uncle, right? So that will be across multiple levels in that base class. So multi-level is like this, right? Grandparents, parents, child. And hierarchy is like this: grandparent, your mom and dad, your aunt, your uncle. Okay. And these are all different subclasses, and this is the parent class. That's a hierarchy. Okay, so how do we put this into the context of programming? So I'll leave that there. So you can have inheritance by passing the classes into the parameter. Okay, or you can also use the keyword super for the top class. And I'll show you how. Any questions? Okay, so see page 8 and forward. I think there's like 2-3 pages where you can also grab the definition for each of the type of inheritance, and you can add that to your answer page for number 9. We only have 12, so 3 more to go. And then we're done for today. Tomorrow, we're gonna do a little bit of GUI where I'll show you how to add buttons, drop-down menus, image, right? Like all the pictures that you took from Costa Rica. If you wanted to add it to your project program, you can. And I'll show you an example of the project as well for the upcoming days. Okay, so now we are gonna write a program that is gonna be single inheritance, one class to another class. So we're gonna have person as the parent class. And in this class, it's gonna use the name attribute, so self.name. Then we have a second class called employee, and we are gonna use the ID attribute. We're gonna make an object for the employee, and we are going to use it to access the name and the ID from both of the classes to display the property. Okay, this can be used for HR type of program. Let me move this down. You don't have to put this. This is just my notes for myself. So I don't use assigned values for object creation, right? So I'm gonna go ahead and input the value here. So I have the first class called person. And to instantiate the class, I simply say def in itself, that just to instantiate the parent class. Then after that, I would have an attribute, and I want to say that it is none, because later on, I'm going to plug it in. If you don't put anything here, it's not going to like it. So the none here is just a placeholder for later. Okay, where I don't have any kind of value yet, I will put the value in when I create the object. Then I have a second class called employee. And this class inherits from the first class person. Okay. So this is the base class. And this is a subclass. And as you can see, this shows that this is inherit, right? By passing the first class into the parameter here. So I plug in person inside the parenthesis. Then again, I have an init function. Now we are going to say that which one is a subclass. So by using the super, it's going to pull the details, right, from person. As we note that here. And we are going to use the attribute ID, none. Then I have an object called empt0. And this is part of the employee class. So this is the object class of employee. And then here is where I define their name, able, and their ID. So in this program, you can just do this part and it will be done. This is the second option. Okay, this is the second way, right? One way is the top, second way is the bottom. There are two ways to do this. So if I do object assignment, I would plug in their name, their ID, and then print it. And I want to print it as a dictionary. You can see here. And then there would be a break for the line break, new line. That's a new line carriage. A second approach is you can define the class. Same thing as the top. Instead of using none, I just put the n. So what it's saying is this is a variable, right? It's going to store things that I'm going to add in later. A second class that belongs to person. It's kind of like you belong to your family and you use your last name. So last name is the base class and then you as a subclass. Then with that, we have the attribute. Now notice that I'm using XI here because we are going to put that as a placeholder where we would put in I for ID, right? And X is to instantiate from the top class, the superclass. Then I have another object called emp1, and this is where I plug in my values. Jane 1, 2, 3, 4 for ID. This is for name and this is for ID. So this way you actually assign using the equal sign separately. This way you can just create the object and then you pass in the value. Either way it is correct. So the program can be written in two ways, the top or the bottom. And as you can see, we both of these have inheritance, a single inheritance. And so when I run this, the top program gives me Abel and the ID. The second program gives me Jane and her ID. So either way, you still have the same output or the same result. Any questions? And you notice that when you have a subclass, when it inherits, you want to say that it's going to pull from the superclass here. So you're using the super. And instead of using the init, you define an init here, but you're going to say dot init x because it's going to pull from the top class down as well. And then you would have ID. Okay. The same thing with the top. Now, some faculty, when they teach Python, sometimes they stop right before class objects. I feel that you should at least be familiar with this because if you do take additional Python classes, it helps if you understand this. So because all the libraries, like I said before, are written with classes, and also when you write your object-oriented program, it is better that you understand the structure of a class and how to use a class. Okay. So for those students who want to go into data science, it's good that you understand this part because a lot of the things that you use in data science, the NumPy, pandas, stuff like that, the methods are member methods of all different classes. So when you generate an error or when you read the documentation on how to use some of the functions that in that library, it's a lot easier if you understand classes and inheritance. Okay. And then just learning coding, to be able to know this is also good because it's applied in a lot of different languages as well. Any questions? So if I put this into the application of my project, right? Let's say that I'm doing a search animals project for Costa Rica. I would have class, right? So first I would say animals, and then within that I would have subclass, like I would say mammals, birds, reptiles, etc. And I would break that down and be able to apply some of the class variables across all the inheritance, right? Like length of the animal, color. So I would say self.length, self.color. Any questions? Okay, so should we move forward now? Okay, so we're gonna do one more with the class. This is gonna be multiple level inheritance, and then number 12, we're gonna do a little bit of data visualization. I feel that it's more interesting that we apply the the stuff that we learned from Costa Rica. So for 11, we're gonna do a multiple inheritance from multi-level. We're gonna have school, and that's gonna be the parent class. Then the attribute is going to be school name and course. Then, oh, I'm sorry, course is going to be your subclass or your child. And course name is going to be the attribute. Room is going to be the grandchildren or the derived class. And that's going to be your classroom number. Okay. So this can be extended from the previous program that we did for our student class program, right? We can add this to it to make sure it's a complete like scheduling application. Okay, so here is an example of that. First, I have a class called school, and this is your base or your parent class. Really easy when you would start with an init function, just like before, you would do a self and then your attribute, school name, and we would put none. This is, remember, that this is just a placeholder for later on. I have a next function. I want to use this function to display the school name. So I would say show school, and I would say print self.school name. So I define, right, my variable here, my member variable, and I would then use it here to show. Then I have the child or the subclass called course. And this is going to inherit from school. Now, unlike C++ and Java, you don't have to specify. You can use public and private in Python, but when you do inheritance, it's going to be directly. This is multi-level. So this is going to be the base, the parent, the child, and the grandchild. Okay. So course is going to inherit from the base class, which is school. That's why you bring the name of the class here. And since it's a subclass, you are going to say super.init. And I'm going to I'm going to instantiate the variable course name. And again, I'm going to use the none keyword. I want to display it. So I have a function called show course and display the course name. So you can see that school is going to be the parent class, course is the child class. Now we have the third class, which is the grandchild, which is room. And room is going to inherit from, right, course. So this is multi-level, level 1, level 2, and level 3. So with that, we also say that this is a subclass of course. So we would use the, inside the init function, we would say super.init, and we would show room number, none, right? So the second function, show room, we're going to display the room number. So after you have the classes and their member function, you would create your object. You can name it anything you want, preferably use short names. So I want to create the one object called C1. And with C1, that is the object of room, which is the bottom class here, the grandchild. And it's going to be able to access school name, which is going to be the top from the top class, right? From here. So as it inherits from the grandparent, we are able to access this attribute. Okay. So I would say MVC. It's also going to inherit course name from course, which is the parent class. And we would say the course name, Intro to Python, and then the room number from its own class, I would say 16. So using multiple level inheritance, you're able to pull the attributes from the base class, right? The subclass and the derived class, as it inherits from the parents and the grandparents. So we're able to access those attributes. So once I define my object, I would access the attributes. Then I would use the object to access the methods, which is the show school, show course, and show room. And that's how we can write multi-level inheritance in Python from green. For OOP, I prefer Python because it's a little bit less in how you would set up your classes. Because for C++, once you have a constructor, you gotta delete it at the end because it doesn't do garbage collection well. So There's additional steps in other languages. So just to let you know, but the concept is the same. You would use the object to be able to access methods and attributes by using the dot operator. Any questions? Move back. So we can fix the TV. Okay. So once you have this, just like before, make sure we run and then capture this for submission of the lab. So it should show MVC Intro to Python room 16, right? Yes, we can do output like to print all of this separately without using classes, but this is how we write object-oriented programs. Are we good with this? Any questions? Okay, so I put together notes for you. Make sure that we go through. It talks about inheritance, local and global variable. I find that a lot of my students, once they work through the classes, sometimes they put the variables in the wrong area and that creates problem. So I added this section just to show you how you can use, right? Local is to the function inside. It can only be used inside, where global, you can use it across classes and functions. And then tomorrow we'll talk about GUI. So I'll touch on this part tomorrow and going forward. Okay. All right, so let's do the last one. This one's pretty fun. So I like to, when I teach advanced Python or sometime when I touch on data science, it's always good to pull data. There are a lot of resources. So after today, if you want to program stuff that's fun, you can go to, like, I don't know if you know about Kaggle. So they have a lot of challenges if you want to make good money. If you like, sometimes they give away like $10,000, $30,000 if you win their challenges. So a lot of it is to solve. If you go to competitions, you can see there are various. Some of it relate to medicine. Sometimes it could be for the NFL, like right now, right? First and future player contact detection, 100,000. There are, various competition that you can participate in and win a lot of money. Some of my friends that take training with me, I'm currently finishing my data engineering course with Georgia Tech, and Clark University. they actually won some of the like $10,000-15,000 from various challenges. So you can do this if you know how to do data science, problem solving. So a lot of it is to look at data and be able to do analytics with it. So there's some cool stuff here. If you look for data sets for fun, they have some really cool stuff like tweets, Netflix, traffic accidents, you know, games, Animal Planets, all kinds of stuff, birds, and so on. Okay. So what I did was I actually created a data file for you, and I used some of the materials that I got from Costa Rica. Number one, the bird pamphlets that I got from the Eternal Forest, Children's Eternal Forest, and I had input all the centimeter of the length of the birds, and then I put down. So let me show you what the data set looks like first. So first, you need some form of data, right? Whether you download it or you create it. A lot of the times when you pull data from other websites and things, you're going to find that it's dirty data. We spend a lot of time cleaning up data that has missing cells, you know, information. So you have to kind of clean it up. So I try to give you as clean data as possible. So you have 3 columns, okay? The bird species, these are all the type of different birds, including the toucans that you saw, some of the birds that you saw in different part of Costa Rica. And these are the type of species that you would see in the cloud forest in different region. And this is their length in centimeters. So you have to have some form of, you know, numerical value. So we have categorical data, which is like name, yes, no, that type of thing. And then I put down, these are the bool data, whether we saw it or not, right? So I went down and I put down, so based on the pictures that I collected and the notes that I have taken when we drive or when we visit different parts. So the ones are the ones that we've seen, the 0 are we didn't see, right? And so you can add or subtract from this data set if you like. Okay, so it's only 3 columns. So it turns out that there's 250 species that were recorded, right? And then their length. So I need you to download that from your assignment page, which is found here. So just click the arrow down to download. Make sure that this file is with your code, okay? It will not work if you store it in a different folder. So when you click download, it's going to be in your downloads folder. Copy it to where your Python file is going to be. Okay, so if you have it on USB, make sure that you put this CSV file on your USB. So anytime that you work with data, it is best that it is in comma separated type of file like CSV that works across multiple platform and application. Okay, so number one, make sure that we save it to the area where our Python code is going to be. Take a look at your data and look at how your column is named. It has to be exactly like how it's typed, right? So if there's an underscore, make sure that you code it that way. Okay. Okay, so here is my number 12. So I'm going to go through the first part first, okay? And then I'll go to the graph section after. So we are going to use a library called CSV. This allows us to read the CSV file that we downloaded, okay? And you can use this as part of your project as well. Then we are going to use a library called Pandas. And if your IDE doesn't recognize this library, you can go to Tools, Manage Packages, and in here you can search. So anytime that you import in your library, you should always install them, right? See, I already installed, so when I click on it after I search, it would show me uninstall. Now, if your computer doesn't have it installed, you would click install. Right? So again, Tools, Manage Package, and I would search for the library, Pandas. That's the library that I'm using here. So I would click on it and then click install. Okay, make sure that it is installed as you are using it. Otherwise, it's going to throw an error. So Panda is used to build data frame from your CSV file. Anytime you work with data, you have to make a data frame. Otherwise, the application will not be able to access your data. Okay. So whether I downloaded my data from Kaggle or I created a data file, right? You have to have a data frame. This right here is going to be for your graph. Matplotlib pyplot. That is going to be used for your graph. And I'm also going to use another library later on, and I will show you. Okay. So the first line here is called rows. And this is going to be, it's going to bring in the row. Okay. Coming, oh, sorry, wrong data. Each of the row here, it's going to have to parse it, right? So we are going to take that and put it on the list. Okay. So I'm going to have a row list. And I'm going to use the with open statement. It's going to read my CSV file. Okay. So I would say with open birdcr.csv. I'm going to have a blank space for the new line. So it's going to read each row, row by row. That's what I want. Okay. And it's going to put it into the location called file. I need to create a reader. So this, using this library, you have to make a reader where it's going to access the CSV file from file. And it's going to be able to pull the data content from the file, the birdcr.csv. Header is considered a column. It's going to go one column at a time. Okay. Then I have to loop through row by row, and as there's 250 species, it's going to go 250 times through the loop. And each time it's going to append the row into this list. So this list is going to get longer and longer as it goes, right? So when you run this program, you will find that it is going to be a little slow as your data set is large. Now, I only have 250 rows. If you look at other data like this on the web, there are thousands and millions of rows, right? For example, if you're looking at COVID cases, it's going to be a lot more. So you would need to have a powerful system to do data analysis, whether you're using R or you're using Python, right? As it's going to store data locally as it reads your data for the application. So we want to use a powerful system. So you do see a little bit of lag. And as it does that, it's going to print out my column and row. So once I read my file, I'm going to build my data frame. The reason why you want to read your data file is that you want to make sure that all your data is clean and it has content. Sometimes there's missing data, then you have to go fix the file. Okay. You can automate it through the program too, like plug in the missing data as 0 and so on. So here I'm going to say that my data is going to be read from this file. And it's going to take that data and it's going to create a data frame called DF. And you want to frame it. So when we're using the data frame function here, what it's going to do is going to take your columns and row and it's going to put it into a frame, which is a table that it can use, right? So CSV file is a form of table, but application needs to convert it to a frame where it is a format of a table that it can access. So that's the next step. Read the data. Second step is to frame it. Then we want to print out the data frame so we can see that it did it. Now, in the requirement, we want to display some kind of mean or average. And in statistics, we don't really look at average. We actually look at median and mean. Right? For those of you who already took stat, you would know. So here, I want to have a variable called mean1. And the only numerical data that makes sense to get the mean is the length of the birds in centimeter. So we want to print it out. So it's going to use the data frame and the column. So this is exactly like the column name. So you're going to make sure that it is typed the same as your column in the CSV file. And I would use the method mean. And that comes from our library here. Then I have another variable called median1. And just like the mean, what I'm going to do is I'm going to use the median method to identify what is the median of the length of the bird in centimeter from my data set. And I wanted to print bird's length median and be able to pull that from the variable here. So that is simply just displaying my data from the data set, my data frame, the mean and the median. Right? The next part is we are going to graph it. Now there are many choices in graphing. You can use NumPy, you can use Matplotlib, you can use pandas with NumPy. There are many resources. We can use Seaborn. So if you're not sure, you can look at the library documentation to be able to use its feature. Okay. So Matplotlib is a common one that you see. Later on, you're going to see that I'm also using Seaborn. So there are several libraries that we can use to plot. Okay. Okay. Any question on this? Now, having this knowledge is very useful in a lot of areas, no matter where you go, whether it's business, biology, right, psychology. When you're doing research, everything now is all data analytics. It's always good to have a little knowledge on this, and it's just leverage you for jobs, and also, you know, later on when you're working with people who built your application for you, you would know what's going on. Okay, so here is just the part for the print. Okay, I commented this section out because I'm going to show you two different graphs. I'm going to show you this one first. So from line 44 to the end, that's one plot. You can do that. Okay, so what we're going to do is we're going to use NumPy. Okay. And again, you can also pull the library by using tool manage package. And if you don't have it, just type in NumPy. And then click on it. And then click install. I already installed it because I use it for a lot of my classes, including the class that I'm taking. So you can click on install. And I'm also going to use Seaborn. This one you have to install. Click tools, manage. And then you are going to install Seaborn. Okay, click install. This might take like a minute for it to go, and it's going to put it into the Python package for you. Okay. Now notice that I put this later on because this section is really going to be for my plot. Sorry, let me bring this up a little bit for you guys to see. So for the plot, you can only do this one. But if you like to do other plots, I also have another graph here. Okay, that's another option. Okay, so let me explain to you what we're plotting. We are going to use the NumPy library and we're going to plot the median. We're also going to use the Seaborn library. This is often used for statistical analysis. And when you bring it in, you want to give it a name so that way the system can refer to it quickly. You can just say import NumPy, but we want to do is we want to say from NumPy, we're going to import the median. That's the only area that we're going to use from that library. And then we're going to import Seaborn and we're going to call it SB. Then we are going to analyze two columns, the bird species and the length. And you can do the third one, but those are just bool data. So you don't have to do all of your columns. So just pick the columns you want to analyze. It needs to be more than one. So you won't have X and Y. It's two-dimensional graph. Then I'm going to frame it again. And in this time, I'm going to use DFR. And it's going to read the file. And it's going to use the columns from that file. And I'm going to do a bar plot. So those are like the bar columns plot, right? So for my X, it's going to be the bird species. And for my Y, it's going to be the length in centimeter. And I'm going to use the median as the estimator. And then when you're done, you simply say show. But you need to say PLT, right? That's going to be your plot dot show. And you notice that it's in the other one too. Okay. So I'm going to run this one first. The one on the bottom here, starting with line 43 to 50, including the mean. So when you run it together, first it's going to display the numerical values. Then it's going to pop up a little window and it's going to default to the size of that window and it's going to show you the graph. It's not exactly the cleanest graph because we have 250 species. It's going to try to fit it into the space that's being displayed, but we can also expand it, size it, and program it for specific format and how we want it to display. But at the simplest level, I want to show you how you can do a two-dimensional graph, right? As we promised in the course. Okay. Now, as I have this up, I'm going to show you this. This is another graph. And in this one, I'm using the matplotlib as I imported earlier, and I would use it as the PLT here. And here I wanted the graph to be a 10 by 7, so you can have it as a dimension with the figure size here. And then I can have it auto layout. So it's going to default to how it's normally is used in the display. And then I would specify my column just like the other ones. I would frame it. I would have it read my file. And then I would have it plot. And then every time that you want it to show certain things, you just have it to use the show method. Okay. So we're going to do this one first with the display of the mean and the median. So this is all the bird species, okay, length in centimeters. And you can't see the text here because it's trying to fit 250 species on here. So ideally, we can make this graph a little bigger, right? A lot bigger so we can see it a little bit more clearly for the X. That's going to be our bird species, and then for the length. Okay, so this is how you visualize your data with Python. And then on the bottom, as you can see, it reads all my data. Okay. And it shows me the data frame. And then it also show me my bird's length mean is 28.76. The median is 20. And then there is my graph. So you can do this with monkeys. You can do this with men in Costa Rica. As some of you want to do that for your project. You can do this with, you know, animals, land, plants. There were actually really interesting data. I was digging into it and they were talking about like the type of strangling figs, like, you know, those vines that grow on top of other trees and it kills other trees. So there were other species like that if you're interested in plants as well. But let me close this so you can see the rest. So once you have that successfully ran, you can screen capture and then I will uncomment the middle section and I will show you what that graph looks like. So the reason why I want to use this is I want to show you that you can do a dimension for your graph. You can also like change the color of how you want your graph to look. There's also pie chart. There are tons of different charts. So I would encourage you to look at the documentation. They show you an example on how to use the graph, especially if this is the area of interest for many of you who are going to stats. Or applied math. And also research as well, right? I like Python, but you can also do this in R, which is slightly different in the language, but concept is the same. You frame it, and you graph it. So if you go for data science, the beginning classes like intro to data science or foundation for data science, like UC Berkeley Data 8, which is what we have parallel here for foundation of data science that's offered in fall of 2023. This is the beginning of that, right? You would see that Python or R is being used to visualize data, but you can also clean data with programming too. Okay, so I'm going to uncomment this out. Oops. And I will show you what the other graph looks like. And I'm going to comment this. So you do a block comment with 3 single quotation mark. So it won't run this last part now. So this one is slightly larger graph, and I'm not using bar graph for this one. This is just simply like a line graph, but I also have X and Y, right? Here's my bird species, and this is the length. So it does show some relationship with the length. But in this one, I don't really relate that to the median. So it is not as clean as the other graph. All right. So this is what it looks like. And that's a 10 by 7. And so you can do this for sales, all kinds of things, as long as you have a data set that you can work with. Okay. So I'm going to show you also where you can find some cool data. So you saw Kaggle, you just have to sign up like using your Google account. There's also data.gov. And then also there is some Costa Rica data available via one of the biology website. So there are different types of data that you can find for state. There's so many, right? You want in CSV file, that's the easiest way, but sometimes for web application, we would use XML and JSON. That's using JavaScript, okay? So you can look at like, you know, even student loan data, crime data, all kinds of different data. So you can download the CSV and you would see that the data set's pretty large. So for City of LA, you can also find like the crime rate for 2020 to present. That's going to be high. Okay. And then we can use Python. So simply save it to your code and then you still be able to graph it. Just change your data file name and your columns name, and you should be able to graph it. Okay. Okay, let me show you. 20 meg is not too large. It's still downloading, but okay. And then if we want to look at how you can use plots, you can go to matplotlib, right? There's some example. Click get started. It will show you how you can plot like line, oops, like this. And then if you want to do like stack bar, broken graph, all kinds of graph like this. Okay. So if you want to consider this for your project, you can. Any questions? Okay, let me stop recording.